Okay, welcome back, guys. Okay, now I'm going to discuss another topic on this fundamental of atom as well. We are going to discuss about isotopes. Okay, guys, I will tell you a simple way to memorize or to remember what do I mean by isotope. As you can see over here, isotope, from the spelling itself, we have a S over here, S over here, and the P over here. Therefore, isotope can easily say a atom that have same proton number. Same proton number. Therefore, guys, isotope is a element, is an atom that have is the same element, such as over here we have hydrogen atoms, we have those chlorine atom, carbon atoms, and we do have a chlorine atom over here. So what are the things that I notice? All are hydrogen, but guys, do you notice or not, it's all have same proton number, but the nucleon number is different. Nuclear number is different. We have discussed in the previous video that the nuclear number is actually the plus the number of a proton plus with the neutron in a nucleus. So I can say it is the same atom, of course the same atom, but different in the mass number. This is also called as a mass number. So as you can see, the next thing, since those are a neutral atom, is a neutral atom, therefore it's going to have a same proton and electrons, total proton and electron for each of those elements, but it have a different number of neutron. That is what make it called as an isotope. It is the same element, same proton number, but have a different the mass number, total different than neutron number. Since guys, those are the same atoms, therefore have a same number of electron. Since it have a same number of electron, it's going to have a same chemical reaction. When it have a same chemical reaction, hence it have a same chemical properties. Please keep in mind. But nevertheless, guy, do you notice or not, those elements have a different nuclear atomic mass, mass number. Therefore, it's going to have a different physical properties in the sense of the melting point, boiling points, and also the size of the atoms will be different. But nevertheless, they have the same chemical properties, different physical properties, but they still have the same formula for each of it. So guys, those are the very simple definitions for the terms that we normally look: relative mass of an atom and molecule. Guys, please remember, atom here refer to one and molecule here refer to more than one atom. So the definition, of course, we took carbon 12 as for the standard to measure the relative isotopic mass and also relative atomic mass. Why we take carbon 12? There are certain reasons. First of all, it is the most abundant elements, easy to find, and also it is more stable. It is very stable, and also it can react with the most of the substances. Before carbon 12 will take as a standard, scientists yes do have other element. In the early development of the periodic table, scientists do take hydrogen and oxygen, but they found out that those elements are not really suitable for the measurements. It is because of the reactivity, or in the not in the gas state, it is in the gas state, and so on. So we have slowly moved to the next part. Those are the definition for relative molecular mass. Please remember, molecule over here stands for more than one atom. Therefore, over here I have a H2O molecule. So from this formula, guys, I found that the hydrogen H2O, I have two hydrogen atoms and one oxygen atom. Since it's more than one atom, therefore we call it as a molecule. So what is the relative molecular mass? The relative molecular mass, you can find this by referring to the periodic table. where I have two hydrogen. This is the mass of the hydrogen atom, and this is the mass of the oxygen atom. Therefore, 2 times with the hydrogen and the 1 oxygen, I finally get the relative atomic mass of hydrogen is 18. So now guys, let's slowly move to the most important, and most of the students have the problem to understand this: isotopic abundance. Guys, let me explain one by one, clearly and slowly. Guys, when you have a periodic table of element, you will refer to the elements. Wait. Okay guys, when you have a very good periodic table of element like this, you will notice most of the elements over here, you will find the mass. But please keep in mind that those mass is the, let's say take a sodium, the stated mass is 22.9 and etc. You might have a bit different value compared to mine. Well, my one is of 4 significance. So guys, all the mass that's stated in the periodic table of element is actually an average mass. Why I'm saying so? Let's say guys, I take a very good example. We take hydrogen. In a previous slide, I have shown you about this hydrogen. Hydrogen itself, from here, I notice I have 3 hydrogen isotope. So the one in the periodic table, the mass of the hydrogen that's stated over here is actually an average mass of all the isotope that we can find. The same go to carbons. If you look over here, it is carbon is stated at 12, and we have a chlorine. For information, chlorine itself, guys, we have chlorine 35 and chlorine 37. But as you can see in your periodic table of element, the mass of the chlorine is 35.5. Why so? This value is actually an average of those 2 molar mass. So that is the reason why we are going to learn isotopic abundance in order to calculate the average mass of an element or an atom by looking at all the possibility isotope that can be found in presented. We take it so isotopic abundance is the abundance of each isotope in the mixture. Remember, we have a chlorine 35, 37. So those are the abundance. But please keep in mind, guys, those abundance presented our environment not in an equivalent percentage. Maybe isotope 35, chlorine 35 are they have a different percentage. As you can see over here, we find scientists find that chlorine 35, the isotope 35, is presented naturally 75.5%, and scientists found that the isotope chlorine 35 only can found as much as 24.5. Therefore, we can say the ratio of 35 and 37 can be represented like this. So we have isotope 35, we have isotope 37. Therefore, the ratio is 75.5 and 24.5. Guys, keep in mind that we noted when you have all those percent, this is actually the percentage. When you plus, it must equivalent to 100%. And we simply can convert this into a ratio of 3:1. So next slide, I'm going to teach you how to calculate the average isotopic abundant mass. So we slowly go into this. We take another example, isotopic abundance mass for elements that do not have isotope. Yes, most of the elements have the isotope, but some of the element doesn't have any isotope, such as fluorine. The relative atomic mass is same as the relative isotopic mass because it doesn't have. Therefore, in our environment, we found fluorine will be the one exist and it is 100%. We depend on the mass. For element that has the isotope, hydrogen, chlorine, and also carbon, relative atomic mass is calculated by multiplying the relative atomic mass of each and this one. So in a simple word, we are actually calculating the mean, the average of the atomic mass for the elements. So let's move to this. I show you how to calculate the atomic mass. Let's say, guys, silicon itself, scientists found that it have a 3 isotope. We have a silicon 28, 29, 30, and silicon 28 that found in nature is around 92.21%. Those are the percentage. And silicon 29, it is found to be 4.70, and this one is 3.09. So how to calculate the average relative atomic mass? It's very easy, guys. As you can see, this is your molar mass, this is your isotopes 28, the nuclear number, and we have this one is this is a percentage, and remember this is your mass, relative atomic mass, and this is your percentage from the one given over here. And this one again for 29, I have 4.70. I multiply these two value and I plus with 30, multiply with this value, and finally remember, guys, when I sum all of this, it's equals to 100%. Then I divide this with 100 as shown over here. So I have, when you calculate this, the average mass that I'm being calculated is 28.1. So guys, when you quickly get a periodic table of element and you look the atomic mass of silicon, you will find, oh, it match exactly what we have calculated. Maybe a bit different in terms of significance number, but the value that's stated in the periodic table is actually calculated based on this calculation. Please keep in mind, guys, sometimes the question, they not really give you in percentage, they give you in the ratio. Please do not be confused. If they give you in ratio, do not be scared. Just use whatever ratio they give you. The formula is still the same, molar and the molar mass times with the ratio plus with the molar mass with the ratio are the isotope, and you divide by, now it's not 100%, you sum all the ratio. So I will show you example. I will definitely show you an examples. Okay, so guys, I will discuss on my next slide about the mass spectrometer. Please stay tuned with me about the topic I will explain soon. Thank you for watching. Please subscribe to my YouTube channel. See you guys.